Okay. So these are the pre-emphasis or de-emphasis circuits, which is used to improve the signal quality. So here it is. So the pre-emphasis and de-emphasis noise produced in the electronic circuits, which is affect the signal to noise ratio, the quality of the signal. So that is nothing but internal noise is added to the signal. So in order to improve that signal quality, you have to use some sort of amplifiers also. So if you use the amplifiers, so including of the signal noise level also amplified. So it's not the case. It's not the desired signal. Noise is the unwanted signal. So along with the signal, noise also improve while using the amplifiers. So to improve without noise improvement, go for one of the important concept in the communication is pre-emphasis network. So in general, the noise quality deteriorated at low frequency levels. Deteriorated at low frequency levels. So whereas to improve the signal strength, use the pre-emphasis networks. Let us see this. This is the block diagram for pre-emphasis and de-emphasis. There it is. M of the signal is given to a filter. The filter has the transfer function HP of omega. Filter have the transfer function HP of omega. You know the transfer function that is the output by input. So you use that filter. M of the signal is filtered out, and that is after filtering, the signal is converted to the emphasized signal. That is MP of T. Let us see that MP of T is the notation there after filtering of that. What the filtering after using the HP of omega, a transfer function, the conversion of M of T signal into MP of T signal. That is here the level of the signal has to be improved. So this M of T is the baseband signal. The baseband signal level is enhanced by using a filter with MP of T. So MP of T is a level improved signal. So like an example, M of T signal have the voltage level of 0 to 2 volts, whereas MP of T signal is the voltage level of 0 to 10 volts. So likewise, the improvement is taken place. So the enhancement is taken place. So by using the filter one. So now this is the process of enhance. The voltage level has to be improved. So original level to some sort of hypothetical level. So that is given to a FM modulator. That is given to FM modulator. So students, please be note that the pre-emphasis and de-emphasis networks are used in the frequency modulated signals only, not for amplitude modulated signals. One of the frequency modulated signals use the pre-emphasis and de-emphasis networks. So before modulation, that is FM modulator, can use emphasize the signal with a filter, that is M of T signal converted to MP of T. So then the signal is modulated. Modulated signal is given to a communication channel. The communication channel, one more added factor is noise. One more added factor is noise. So you can treat it as the noise is a white noise. You can treat it as the noise is a white noise. Now this is signal. So along with the amount of signal, noise is receiver, the receiver section. The receiver section has the carrier filter is there, and again the FM demodulator is there. FM demodulator. After demodulation, the signal is MP of T plus N of T signal. MP of T plus N of T signal after demodulation. After demodulation, you can use the de-emphasis network. The de-emphasis network is again the filter is used. The filter have the transfer function is opposite that of the transmitter filter. if the transmitter is that HP of omega, no? So the inverted transfer function is applied here in the demodulation side. So that is the filter having the transfer function is 1 by HP of omega. 1 by HP of omega. That is inverse of the transfer function in the receive section. That is, this filter can act as de-emphasis network. So the transmitter filter can act as pre-emphasis network, and the receiver filter can act as de-emphasis network. So now the before de-emphasis filter, the signal is MP of T plus N of T signal. That is given to the filter again. The filter output is so when noise is there, and that is given to baseband filter. The output is M of T plus N of T M of T plus N of T. So this is the entire preemptive and deemptive. So what you are doing is hypothetically increase the signal level from M of T to MP of T, and at the preemptive network, and the deemptive network again you can deconvert from MP of T signal to M of T signal. MP of T signal to M of T signal. So the conversion is M of T to MP of T at the deempsis. The deempsis MP of T signal is deconverted to M of T signal. So this is the network service. So in this, you can observe here block diagram. Before modulation, you use the preempsis network. Before modulation, you use the preempsis network. After demodulation, use the deempsis network. Before modulation is the deempsis network. After demodulation is the deempsis network. So this is the block diagram of a network of deempsis and deempsis. So here it is. So what the preempsis do? So a preempsis circuit is a high pass filter. Preempsis circuit is a high pass filter. That is an RC circuit is given in this one. So that is capacitor and resistor is RC circuit. We need to construct a high pass filter, and the circuit and frequency response curves are preempsis network is like this. So then use the circuit as a modulated signal given here. Modulated signal means M of the signal given here. After resistor, that is signal is amplified signal. That is, this is used as a filter at modulation side or transmitter side. Okay, so now the preemptive circuit is nothing but high pass filter used. So that is constructed with using RNC circuit, RNC elements. So this is the response, and the DMC circuit is a low pass filter circuit. Opposite of that, no, the low pass circuit is this. So that is high frequency component are activated. So because of low pass filter, high frequency component is activated. Low frequency is available. Okay. So this is the circuit is DMCs. So this is the transfer function. So whereas this PMs and DMCs networks are used by using low pass and high pass. Low pass circuit is a DMCs, high pass circuit is DMCs. Okay. So why you are using this DMCs is, so in the communication at the receiving end, if there is any distortion, that has to be compensated, that has to be eliminated by using this PMs and DMs. So initially, so for any system, by using a system using a frequency modulation. So at the receiver side, you can estimate how much distortion is taking place. How much distortion is taking place. So accordingly, the preempsis is done. So how much distortion is taking place at the receiving end? Accordingly, the preempsis is done at the transmitting end. So that's why initially you have to select de-emphasis network first. De-emphasis network first, because of you have to estimate the signal distortion. So after distortion is estimated, the preemptive network is then later initiated. So these are the important topics in the communication. So in general, at high frequency component, the distortion is taking place. In order to eliminate the distortion, you can go for some sort of this preempts and preempts. Okay. Okay, students, this is a concept of noise also. Okay, so now you enter into the another concept that is pulse modulation schemes. Pulse modulation schemes. So okay, so it is the pulse modulation system. So this is another modulation scheme. Already you discussed analog modulations, which are amplitude modulation and angle modulation. Within angle modulation, there are the frequency modulation, phase modulation. So amplitude modulation definition is amplitude of the carrier changes according to the modulation changes. Amplitude of the carrier changes according to the modulation changes. So whereas in the frequency modulation or the angle modulation, angle of the carrier changes according to the modulated signal changes. Angle of the carrier changes according to the modulated signal changes. So whereas in the pulse modulation schemes, this is another scheme. In the present chapters, there is amplitude modulation, frequency modulation. We shall discuss in the present chapter, we will discuss a second method of multiplexing. Whereas in the first method of multiplexing is carrier and modulated signal are superimposed. So that has to be multiplexing takes place. So in the second method of multiplexing depends on fact that a band limited signal, even if it is consequently varying function of the time. So maybe specified exactly by samples taken sufficiently frequently. So multiplexing of several signals is the is then achieved by interleaving the samples of the individual signals. So see this statement. Multiplexing of several signals is then achieved by interleaving the samples of individual signals. So because of interleaving of individual samples, the signals are multiplexed. So now the here can use the terms. One is the signal, another signals, another one of the term samples. So when the samples are interleaved, then the multiplexing of signals are achieved. So this process is called time division multiplexing. This process is called as time division multiplexing. So since the sample is a pulse, now the system to be discussed are called pulse amplitude modulation. Okay, so this is the second method of multiplexing. What the second method of multiplexing? The interleaving of the samples, then the signals are interleaved. Signals are multiplexed. This process may called as pulse amplitude modulation system. Pulse amplitude modulation system. So the pulses are now. What are the pulses? So here the pulse modulation, pulse amplitude modulation. The pulse amplified modulation systems are analog systems. They are analog systems and share a common problem with AM and FM. Okay. So earlier we discussed the AM and FM. Same common problems are added in the AM also. Because of it is also an angle modulation, analog modulation system. It is also analog modulation. So that is each of these analog modulation systems are exactly the that is each of these analog modulation systems are extremely sensitive to noise present in the receiver. So these analog modulation systems are most sensitized to the noise. Sensitive to the noise. So all the analog modulation systems are sensitized to the noise, but the digital modulation systems are less sensitized to the noise. So now the analog modulations are more noise than digital modulation systems. So now pulse modulation also analog modulation scheme. So like in AM and FM, the pulse modulation system also pulse modulation system also having the more noise. Okay. Okay. In this chapter, we consider how to convert analog signal into digital signal. How to convert analog signal to digital signal, pair to modulation. Pair to the modulation. So how can you convert analog signal to digital signal? Also can discuss in this chapter. So such a conversion is called as source encoding. Such a conversion is called as source encoding. When the digital signals are modulated and transmitted. So the receiver signals is far less sensitive to receiver noise than an analog signals. So that means digital signals are less sensitive to the noise than analog signals. So because in this chapter, before modulation, you have to convert analog to digital conversion also. So like an example. So for example, a 1 kilohertz telephone cable may be expected to produce an attenuation of 1 dB per mile. So please be see this example. So there is a cable having the frequency is 1 kilohertz. The telephone cable have the attenuation of 1 dB per mile. 1 dB per mile. So there is a cable that is path that is a channel. Cable is one of the channel now. That is the cable. Voice signals are so, in the cable 1 dB per mile is at least. So for a 3000 mile run is there. Such a cable have to be covered 3000 miles. 3000 miles. Even if we are satisfied with the received signal of 1 milliwatt. What it means? So you have the cable. So the frequency is 1 kilohertz. So for the cable, there is attenuation of the signal for 1 dB per mile. So such a cable have covered 3000 miles. 3000 miles. So how far it is signal is attenuated? For that cable, at the receiving end, can expect 1 millivolt signal. At the receiving end, at the transmitting end, signal is given. At the receiving end, what is the length of the transmitter to receiver? 3000 miles. Such a cable is used. The cable have the properties that is the attenuation of the signal. Signal going to be attenuated 1 dB per mile. 1 dB signal is attenuated per 1 mile. Such 3000 miles are there. So how much signal is attenuated? After attenuation of the signal, you have to receive 1 millivolt signal at the receiving end. So how much the transmitted signal now? How much the transmitted signal now? If you calculate that, transmitted signal is 10 to the power of 147 volts. If you given the input signal is 10 to the power of 147 volts, the received signal is 1 millivolt only. See the difference. The transmitted signal is 10 to the power of 147 volts. Even the received signal is 1 millivolt only. For the 3000 miles cable is used with the telephone cable. For the cable have 1 dB per mile. Is the attenuation. 1 dB per mile is the attenuation. So see that. Is it possible in the practical case in order to use 10 to the power of 147 volt signal? Is it possible? No. So such a huge signal is not able to given at the input side. Yeah, quadruple. So there is a recovered. There is an signal strength improvement is by using one sort of an amplifier at the receiver will not have the above situation. Amplifiers will not have the above situation. Since at this point both signal and noise level will be increased together. If your amplifiers are used along with the signal noise level also increase. But suppose that the repeaters are used. What is the repeater? Repeater is the term used for an amplifier in a communication channel is located at the midpoint of the longer communication path. So the repeater means regenerator. So the repeater means regenerator. So these repeaters will raise the signal level only, not the noise level. So medicine, it will raise the level of only the signal level, not the noise level. And such a mid-way repeaters are considered with the amplifier at receiver as advantage of improve the received signal to noise ratio. This midway repeaters will used to improve the signal level. Used to improve the signal level without using amplifiers. Okay, so this is the process. Okay. If you now here to transmit the digital signals for the same channel. So that is the previous one is analog signal channel. The digital signal is transmitted at the same channel. You will find that significantly less power would be the need to transmit than the analog power. The analog signal is used. How much signal is you have to give? 10 to the power of 147 volt signal is used. So if it is the analog signal, if the convert that analog signal to digital, then less power is used. So that's why the advantage of digital. So in order to use the less power signal to avoid the attenuation. So the reason for this significant parameter is now not the signal to noise ratio, but the probability of mistaking a digital signal for a different digital signal. In practice, we find that signal to noise ratio of 40 to 60 dB, 40 to 60 dB are required for analog signals. So see this statement now. So in practice, we find that signal to noise ratio of 40 to 60 dB are required for analog signal, while 10 to 12 dB are required for digital signal. How much difference is in observed? If you use the analog signal, there is 40 to 60 dB is required. Either it is digital signal, that is reduce it to 10 to 12 only. Use the analog signal, the signal 40 to 60 dB is required, whereas in the digital, that is reduced to 10 to 12 only are required for the digital signal. This reason for others to be discussed subsequently have the resultant in a large commercial and military switches to digital communication. That's why you can use the digital communication is used in the preferred in the military communications and large commercial communications. Large commercial communications. Okay. So, students, it is concluded my class. The next class will go for sampling theorem and followed by pulse amplitude modulation, pulse width modulation, pulse position modulation. Okay. So, thank you.